Hey everyone, welcome back. This is James Brumfield. I apologize for being absent recently. I was learning about balanced trees and binary search trees the last week or so. So I haven't really made a video because that's actually a pretty complicated data structure, and I'm probably gonna have to go back and watch more videos and do more coding to try to get it. But I figured I would take a break and create a video about linked lists. And I know in previous videos I talked about linked lists a little bit about some of the coding challenges I solved a few months ago. But today we're actually going to put together a comprehensive video to talk about linked lists a little bit. So today we're going to talk about four things. We're going to talk about printing the elements of a linked list, inserting a node at the tail of a linked list, inserting a node at the head of a linked list, inserting a node at a specific position in the linked list. Um, so like I said, I saw those particular challenges a few months ago. So if you really don't want to watch the video and just check out the code I did, just go to HackerRank, Data Structures, Linked List, and these three right here we're going to talk about. In a subsequent video, probably in another couple weeks, I'll probably make a continuation of this video to talk about deleting a node, printing it in reverse order, and reversing a linked list. So again, if you don't want to wait for the video, if you just want to look at the code, just come to my GitHub account and just check it out for yourself. So before we even get into that, what is a linked list? So my favorite site today is the Geek for Geeks. So we say a linked list is a linear data structure in which the elements are not stored at contiguous memory locations. The elements in a linked list are linked using pointers as shown in the below image. So essential linked list has two parts, data part and then a pointer part. Now the pointer here is pointing to the next node in the linked list. And then the last node in the linked list is pointing to a node value here. And then the way we transverse through the linked list, we start at the head here, and then we iterate all the way till we get to node. But we'll talk about that later. So I did some preliminary work in my IDE over here. I have my main function. I have my this class called linked list presentation, and then I have a node class. So I'm going to pause this video through time to time just to put comments in, so I could try to get through everything within a decent amount of time, and you don't want to watch me just type in comments. So the first thing we're going to do is create our node class. So let's go to View, Presentation Mode. Okay, so the first thing we need, so as we showed in the picture there, a node has two things. It has a data and a pointer. So what we're going to do, we're going to say data and node. We'll do int. Now I don't know if it could be a string or a char. I'm assuming it can, but just for this demonstration, we're going to assume the data in the node is an int data. Now we need a pointer. The pointer is going to be of type node. So we're going to say pointer, which in I think C++ is called reference. Well, in Java it's called reference, and C++ is called pointer to the next node. So we'll say node next. Okay, so what we want to do when we create a new node, we want to initialize it using the constructor. So we'll say constructor to create a new node. So we'll say public. I probably could use the short keys, but I'm just going to type it out. Node, and it's going to take the data variable here. So when we create a new node, there's two things we want to do. We want to set this value to this value. So we're going to say this dot data equals data. And just as a side note, it took me a long time to understand what this keyword meant. I had to watch 1,000,001 videos to understand what that means. But essentially, this is equals that. This is what this keyword means. And then we're going to say this dot next equals no. So say we create 5 nodes. They each going to have their data, and then the node, they're going to have a pointer that equals no. And later in the video, probably within the next 5 minutes, I'll put some comments in, I'll pause it, and then I'll pretty much talk about what this means here. So that's our node class, nothing too exorbitant, but I don't know how to get to other class, so I have to go out of presentation mode. And we're going to get to our linked list class. So we go to presentation mode. Okay, so now that we have our node class, the first thing we need, the next thing we need to do is create a head. Because if you, early in the video, I said we start the linked list with the head. And that is pointing to the first node. So we're going to say node equals head. That's essentially all we need to do for right now. And this is a pointer. Let me just put a comment in. Pointer reference to the beginning, still can't type, of the linked list. So that's all we need to do for right now. Now, let me go out of presentation mode for a second. Actually, no, I can stay in presentation mode for now. Just to show you what we're going to do. So we're going to create various methods instead of just typing the code in the main method. So the first thing we want to do is print out the linked list. So we're going to say public void print list, and it's not going to take any parameters. So when we transverse through the linked list, we have to start at the head. We have to start here. So we need an instance of this in our method here. So we're going to say node n equals this dot head. And just to put a comment in, create an instance of the node class so we can traverse through the linked list. Okay. So this is our we created an instance of the node class called it n, and we're saying that it's the head. Is the head of the linked list. So we need to transverse all the way until we get to null. So if you remember the picture I showed you, it starts at null. And let me just go back just to remind you guys. So here it is. So we start here, and then we transverse all the way till we get to null. So it's essentially that's how we're going to print out all the data elements in the linked list. So we're going to say, well, in our, actually, let me go back, sorry, presentation mode. Okay, so we're going to say while n, which is the head, while n doesn't equal null, we just do a sys out, and let's do it on the same line. Sys out, we're going to do n dot data plus, do a space, and let's do a actually no, I don't want to do that. Let's do a just to emphasize pointers, we'll do a arrow just to show that the data, the nodes are pointing to each other. Okay, and we need to change the node every time. So we're going to say n equals n dot next. So this moves the pointer to the next pointer here, this line here. So we'll put a comment, change the node, or moves the node. Okay, so that's our print. So I'm going to add some data. Let's go back to, sorry, I got to keep going in and out of presentation mode. Let's go to the main data here and just add some data. And I might be able to print it out before this video gets too long. We'll see. But I'm going to pause it in a second just to put some data in. Okay, so let me go back to presentation mode. So we're going to call it link list presentation. Let's call it sample link list. I'm going to create this line creates an empty linked list. New linked list presentation. There we go. Create empty linked list. Okay. Now we're going to add some nodes. Well, first thing we're going to do is create our head before we add some nodes. So we're going to say create head. So we'll say sample, dot head, right? We're going to say that is, let's say that's 100 because head is a node, new node. And remember, the constructor takes in data, so let's say that's 100. Takes in number, I mean. Okay, so let's create some nodes. So we'll say node. Now, we create nodes using the node class. So we're going to say node, let's call this first, equals new node. Call this 200. That's not what I want to do, I'm sorry. New node 200. Node second. Let's create 5. 5 is a decent amount of data to work with. New node data 300. Node third equals new node 400. And node fourth equals new node 500. I'm going to pause the data for a second just to show you what these lines really mean in memory. So I'm going to pause it right now and be right back. Hey, welcome back. So I just paused the video for a couple of minutes just to type out some comments. So I just want to go through this comment here to show you what these lines up here really mean. So at this point we have 5 nodes. 1, 2, 3, 4, 5. Each node contains the data and pointer when we create an instance. So when we create an instance and we call it a constructor, there's 2 things that are happening. If we go back, well, yeah, we could go back for a second. Go to view, come on, view, full screen, and then we'll go here into presentation mode. So there's 2 things when we call the constructor. The data that we passed here is being assigned to this here, and then this here, this pointer is being assigned null. So when we go back to here, oh, sorry, wrong one. I apologize, everyone. Go back to the main one. There we go. So when we go back to the main one, like when we create the head, as we assign in a value, and then the null is the pointer is null. We create our first null in the list. That's not the head. We assign it a value 200, and the pointer is null. And then we do the same thing. We assign it the value, and the pointer is null. Now this value is going to change once we link these together. So I'm going to cut this a little. Actually, no, I think I have time. So let's link these together. So the first thing we're going to do, we're going to link the head to the first node. So we're going to do sample list dot head. Now head is a node, and that means it has a pointer called next. Next, we're going to link that to the first node. That's essentially what this line does. Head is linked to first. And then now we're going to link the first node that's not the head to the second node. So we're going to do first dot next equals second. And then we're going to link the second to the third. And we'll link the third to the fourth. I don't think I have a fifth, do I? No. Okay. So essentially, these are all linked. So essentially, this value now this is pointed to this. This is pointed to this, and so on. So I'm running out of time, so I'm going to pause the video and come back and we'll print this out. Okay? Thank you. Talk to you soon.